Yes, hello everyone and good day. Welcome to Here and Now, and this is Man. Okay, so for an online math tutorial, we'll be discussing about asymptotes. Okay, and we'll be using GeoGebra in determining the horizontal and vertical asymptotes of a certain Lucas function, and we will be able to use GeoGebra also in validating the sketch that we have created, okay, for a particular Lucas. So we have to, I'm not saying that you'll just be relying on GeoGebra. Okay, so as math learners really have to know how to determine the asymptote offline without GeoGebra's help, and we will be able to sketch the graph without GeoGebra's help. So in this video, we'll be having the offline determination of the asymptote and how we can validate it in GeoGebra. Okay, so first of all, I'm going to show you where you can find the syntax of the command asymptote. There will be another video in the future, okay, discussing how to navigate the wiki of GeoGebra. But basically, there's an asymptote command that you can call, okay, for GeoGebra to return the vertical asymptotes and the horizontal asymptotes. So we have here the asymptote command. So the syntax is pretty much very straightforward. You just have to type in the whole command name asymptote and then enclose in parentheses the expression. Okay, so you will see, I'll demonstrate how we can call this function, how we can use this in GeoGebra. So what is an asymptote, by the way? So asymptote is a line that the graph approaches but never touches that line. So it can be like a boundary, okay, that sets the region of the Cartesian plane, and it's a boundary for the extremes. So it's for us to know the limits or something like the boundaries of the graph, the behavior of the graph. So that's for the asymptote. And this video is being inspired by the series of videos of Mark Kai. So I would recommend you to subscribe to his channel. There you can have a lot of videos, sketching aids, okay, how to sketch the graph from defining the domain, the range, the intercepts. Okay, so we will be applying what I've learned from his channel in this video. So let's now determine, or let's discuss how to determine the horizontal and the vertical asymptotes. So I have a note here, prepared notes here. So we'll be using one expression or one Lucas for this video. So that would be y equals x over x squared minus 16. So first we'll find the vertical asymptotes. Very simple. We just have to solve for x if y is equal to 0. So basically, it's like finding the roots. Okay, so this is it. 0, y is 0 equals x over x squared minus 16. And then we will be manipulating the equation using the rules of algebra. And we will have this or these roots. So we have x equals to 4 and then x equals negative 4. So this is our vertical asymptote. So if you will draw a line that would touch x equals to 4 and then x equals to negative 4, then you have vertical asymptotes like that. Okay, then finding the horizontal asymptotes. Okay, so here we will solve for y when we set x equal to 0. Okay, so simple algebra. Then you have the horizontal asymptotes, y is equal to 0. That's basically the x-axis. So there you have it, guys. I will be putting some links also down in the description of this video. Okay, some links that you can also watch to appreciate more and understand more about asymptotes. Okay, and then again, I've told you about the channel of Marka I discussing some sketching aids. So if you have a certain expression and because of function, then for you to know where to start in sketching it as a graph or into a graph, then what we need to do first is we need to find the intercept. So in this case, our intercept is the origin, 0, 0. Okay, and then find the symmetry. Okay, so in finding the symmetry, we just have to change the x values to the inverse. So we negate it, so negative x, then negative x squared. Then since the result will be a different function, then we don't have a symmetry along the y-axis. And then if we will negate the y value here in this expression, we have here negative y equals x over x squared minus 16. It's again it produces a new function, a different function. So that would mean that we don't have symmetry, okay, along the x-axis. Okay, and another aid is finding the asymptotes. So we just did that, and next step of this video is for us to design and build a table of x and y endpoints so that we will have an idea on how the graph will behave. So before we do that, I'll show you first the tool GeoGebra here. Okay. So we'll be using GeoGebra Classic. So how to get here? Okay, so you need to sign up. Okay, it's a free app. It's a community of math enthusiasts, and GeoGebra is an organization that is supporting open source. So you can contribute to the GeoGebra community. So you just have to go to geogebra.org, and then you have here the icon for the apps. You can have all of the apps here. You don't have to really install it in your PCs. You can just use it anywhere. Okay, if you have an internet, so it's web-based. All right, so we just have to go to GeoGebra Classic, and then there you go. So it's like really having a web-based app. Okay, there you go. So we will just be will not be creating and designing a table from scratch. I already have prepared one for this video. Okay, so this is the GeoGebra session that I have saved. I have contributed to the community. Okay, so in validating our answer here, that for the vertical asymptotes is x is equal to 4 and x is equal to negative 4, and for the horizontal asymptotes y equal to 0, then we'll go to GeoGebra Classic, and as I've said, the syntax pretty much very straightforward. So you just have to type in asymptote here, the name of the command, and then enclosed with parentheses is the function or the locus, the expression that describes a set of points in the Cartesian plane. Okay, so there you have it here. GeoGebra just returned the values for the vertical asymptotes, and yes, it had validated our answer as correct. So x is equal to negative 4, x is equal to 4, and y is equal to 0, okay, as the horizontal asymptote. So I'll just delete this because we already have it here. Okay, so there you go. If you still don't have the function or the object asymptote Okay, then this is how the graph will look like with the, ignore the other objects there in the graph. Okay, and then if you will call the asymptote command, okay, something like this, and then you let GeoGebra show its graphical representation of the asymptote, then you just have to display it. Okay, so GeoGebra then it's telling us here that we have the vertical asymptotes at +4 and -4. So it's being represented by broken green lines. And we also have here the x-axis y equal to 0 as the horizontal asymptotes. And the beauty about having a visual of the asymptote results, or the visual of a particular locus, then you will be able to analyze further, assess further that there are a lot of regions here. So you might have the curiosity on how the graph will behave, okay, in the plane. So the next thing then we have to do is to manually sketch it. Okay, so we would first of all, okay, we have to define the function here, okay, and then make sure that the graph is hidden. Okay, but then before you consult GeoGebra, do your sketching first by hiding this part, okay, or not showing the graph, and then just analyzing here, analyzing the table that you'll be able to design and build. Or you can also use a paper and then have a table of x and y. Okay, so this is how I did it. And then so we'll not be using this part. So we have here the object properties and the table that I just designed and built. Okay, so how to design the table? So basically we have already some hints. All right, so we have x equal to 4 and x equal to -4 and y equals to 0. So we will be having regions. So we have group of data sets here. So we will observe what will happen if values draws closer to 4 and it's greater than 4, and what will happen if values draws closer to 4 but less than 4. So something like that. So in designing it, then you have to have those questions, okay, and then for you to determine what x values to input here. Okay, so that would be for the first set of this discussion. All right, because we're running out of time. I just have 15 minutes for each video, so please watch the part 2, okay, of this discussion about on asymptotes, so that you will know how I design and build a table, okay, that helps me in sketching the graph of the function y, or the locus y equals x over x squared minus 16. The first thing we have to do then is to open up a spreadsheet, okay, using GeoGebra Classic. So we'll go again to geogebra.org. So again, this is a free app. This is an organization of online math contributors, okay, to make fun learning of math very, very fun. Okay, so we now in the website geogebra.org, so we have here the apps. So we'll go to GeoGebra Classic, and then under Classic, then we'll just have to open a spreadsheet. Okay, so it will suggest what you want, something like that, and then open a spreadsheet. Okay, so we will just be ignoring this one. I'm just showing you how to open a spreadsheet. because I already have built one for our discussion. So we'll go there. So here. Okay, so again, in designing it, I'm considering the asymptotes, the boundaries, and in grouping, okay, the data sets into region, and in order for me to anticipate how the graph would behave. All right, so the first condition, okay, x values will be very, very close to 4 and less than 4. So where is that in the Cartesian plane? What the region is that? So again, let me just check it again. Less than 4. Okay, so this is 4. Okay, less than 4 somewhere here. What will happen? Okay, will it go up here, go down here? We don't know. So we need to plot some points. So we'll consider 3, 2, 1. Okay, and we also, so let's close this one first. I mean, minimize the graph part. Okay, and then so we have 1, 2, 3, 2, 1. So that's less than 4, and we also have 3.99 less than 4, but so a little close to 4. We have 3.99 here. Okay, the correct definition is 3.99, and that's also closer. Okay, to 4 less than 4. We also have 3.9999 and 3.99. It's repeating the decimal here. Okay, so GeoGebra cannot really display a number with repeating decimals. It can only display up to 2 decimal points, and more than that, like 3 decimal points, to round up to the next whole number. Okay, so in order to display the correct definition, you have just entered. Just have to right click on the cell and then click on object properties. Okay, and then you will have this view. So that's 3.99, the correct value you have entered, 3.999, so on and so forth. Okay, so it becomes very, very close to 4, not equal to 4, and it's less than 4. So what happens? So in determining the y values, when having these following x values, you just have, I'll demonstrate it here down below. Right here. For example, 2. So you just have to enter 2, and then for the y column, then you enter equal to the equal sign, then call the function f of x, and what value of x you can enter. So you call this cell with the value 2, and there you go. You call the function and use the value 2 to the function. Okay, and it's -7. And you have the function. Make sure that you have indicated the function in the object pane. This is the function here. Okay, so let's close that. Alright, so let's move on to our analysis for the first group. So as it draws closer to 4, so 1, 2, 3, and then 3.99, 3.999, 3.9999, and so on and so forth, we notice that the values are, we're getting negative values, and it's approaching negative infinity. Okay, so that would be either in the first quadrant or in the second quadrant. And since you have positive numbers here, okay, then that would be at what region. So we will be able to sketch that one here now. Okay, so that would be 1, 2, 3, 4 here. That's 1, and it approaches negative infinity. So this region here, it's that fourth quadrant, and this region here. So we can then draw it in your paper, and just for demonstration here, I'll use the pen. Okay, Okay, so we have the origin here, and then draw it here, like that. Okay, so not touching 4, negative infinity. Okay, so bear with my hand control. So that's for the first part of the data of our table, the first group of our table. And then hide again the graph for a while, and then let's move on to our table. Okay, for the second condition, we have determined, or we have assigned. So we'll observe now what will happen if the x values are very, very, very greater than 4. So these are the extremes. So you have in determining the asymptotes, you have to enter values, x values of extremes. So positive extremes. So we have here 10, 20, 30, 50, 100, up to 200. You have 10,000 will really appear as 0. Okay, so by observing our table here, then we can see that as we're getting as the x values becomes so far from number 4, and it becomes very, very big, positive numbers, then it approaches 0. So the y values approaches 0, our horizontal asymptote. So let's now sketch that in the graph here. So we'll go back to the graph view, to the graph pane. So we're considering this x values here. So it says approaches 0, right? So you can draw that in your paper. I'll use the pen here. Alright, so positive, okay? We are in the first quadrant. Positive, very big values here. So let's do that. 10, something like that. Something like that. Alright, so that's the sketch. It goes beyond going to positive infinity, very big numbers, and then it approaches 0. Okay, so that's for the second group. Now we have another group. Okay, so what if the x values becomes very, very close to 4 and more than 4? So close to 4, that's the 5, this one, this region here, no? 5 to 4, greater than 4, or 4.001 or something like that. So we have this values 5, and then 4.75, 4.5, 4.25, 4.1, 4.005, okay, here, 4.005, 4.001, 4.0001, 4.00001, okay, very, very close to 4, and we notice that it's getting bigger and bigger also, okay, and it approaches positive infinity. So positive, the y values are big numbers. It approaches positive infinity, very big numbers. So there will be a movement somewhere here, right? So we'll draw that. You can draw that again in your paper, and I will show it here using a pen. It's like that, okay? That's the sketch that would draw closer to the graph. But bear with what I have here, okay? So the graph will look like this in this region, alright? So let me remove this. Okay. Now let's hide again the Cartesian plane. Let's move to our next value here. Okay, what if x greater than -4 and then getting closer to -4? So what are our values? We have -1, -2, -3, okay, and then -3.9, -3.91, -3.92, -3.94, and so on and so forth. And we have observed that y approaches positive infinity. So where is that in the region here? Okay, so that'll be 1, -1 here. It approaches positive infinity, right? Yeah. So the sketch then is something like positive infinity. Okay. All right. And I'm running out of time again. The next region that we'll be discussing use when x values are very, very small and far from -4. So what are these values? So we'll start with 5. Okay, -5 I mean. So it's a little far from -4. It's small, I mean less than -4. So we have -5, -6, -7, -8, -20, -50, -100, -200, -3, so and so and so forth, -10,000 if you like. And then these are the y values. Okay, and when we substitute x with these values, so we have observed that our y values approaches 0. So how to sketch that in the graph here? So negative, alright, so the negative x, so it's at the third or fourth, and we have negative y values approaching to 0. So third quadrant, and it approaches to the horizontal asymptote, the y equal to 0. So you can draw that in your paper again, sketch that. So let's use the pen of GeoGebra. Okay. So -5, and then negative this one here. Oops. Okay. Alright. So that's it. And then the last group now, we're down to the last group. What if, for the last question, the x values, okay, are lesser than 4 and going nearer to -4. Okay, so what are these values? So let's start with -5 and then drawing closer to -4 but still smaller than -4. So we have -4.99, 4.9, and -4.5, -4.25, -4.1. Okay, and then we have -4.025, -4.0025, -4.00001, -4. Okay, that's not to infinity. So as you can observe here, the y values approaches negative infinity. Okay, when your x values are smaller than -4, okay, and draws closer to -4. All right, so this part, -5 to 4, so this region here, right? So it approaches negative infinity. Okay, this one, -5, drawing closer to -4, it approaches negative infinity. Okay, all right, so there you have it. We have able to get the sketch, okay, considering the conditions that we have set, having the asymptotes as the boundaries. So what will happen in this region, what will happen in this region, okay, something like that. So you have to have questions, okay, what will happen if it will be far from the boundary, the -4, very, very big numbers, and then what will happen if it draws closer to +4 but greater than 4, okay, and then what will happen if the values are less than number 4 but smaller than number 4, okay, and then what would happen if the values draws closer to -4, okay, but greater than -4. So basically the region of the number lines, what will happen if you have values at the right side of 4 in the number line, and the then what would happen to the y values if you have the region at the left side of +4 in the number line. Okay, and so on and so forth. So you have to use the regions of the number line in order to anticipate what will be the correct set of x values that you can consider in building the table here. Okay, so now that we have sketched the graph, then the beauty of a GeoGebra again is that it can help us validate the sketched graph. So we just have to go to the function and show the graph. Okay, and there you have it, dear math learners. GeoGebra just validated that the graph we have sketched, okay, is pretty much it is correct. Okay, so we have anticipated the behavior of the graph correctly. Alright, so that will be all for our discussion on asymptotes and with GeoGebra as an aid in sketching. Alright, thank you so much for watching until the end. Okay, and till the next video. I hope you enjoyed this as much as I did.